April 1945. The war in Europe was nearing its end, but for a select group of German scientists, the journey was just beginning. They stepped off a military transport plane onto the tarmac at Detroit's Willow Run airfield. Men who had spent years designing engines, rockets, and machines for a Reich that was now in ruins. They had seen the might of German engineering, the precision, the detail, the obsession with perfection. But what they were about to witness inside Ford's Willow Run plant would defy everything they believed about industrial possibility. The air smelled of oil, steel, and relentless movement. Conveyor belts rattled, cranes groaned overhead, and the floor trembled under the weight of thousands of synchronized workers. To the Germans, it looked less like a factory and more like a living organism made of iron and fire. In one corner, rows of women in denim overalls tightened bolts on aircraft engines, while music from a radio cut through the din. Forklifts darted between supply racks stacked with sheet aluminum. Sparks from welding torches flared like miniature suns. Above the noise, an American foreman barked instructions, not to a few men but to entire departments. The Germans followed silently, their polished boots clicking on the catwalk as they stared down at the endless production line. A new B-24 Liberator bomber rolled forward every 55 minutes. They blinked, stunned. In Germany, it took weeks to complete one. Here, machines seemed to give birth to machines. The Willow Run plant, built by Ford Motor Company in 1941, was unlike anything Europe had ever conceived. Designed by architect Albert Kahn and powered by the vision of Henry Ford and his son Edsel, it covered an area of nearly 67 acres under one roof. The main assembly line stretched a mile long, winding through stamping presses, fuselage stations, and paint tunnels. Engineers called it the Grand Canyon of production. At its peak, more than 42,000 workers labored day and night, turning out 650 bombers a month. The statistics alone felt unreal. More aircraft in a single year than Germany's entire pre-war industry had produced in 5. For the visiting scientists, men accustomed to precision workshops in Stuttgart or Peenemünde, the scene was incomprehensible. They had prided themselves on craftsmanship, on tolerances measured in fractions of millimeters. But here they saw the opposite philosophy at work. Mass production replaced perfection. Speed replaced obsession. Quantity has its own quality, a U.S. Army liaison officer told them as the tour began. The phrase lingered in their minds as they moved deeper into the heart of the plant. Each section revealed another revelation. Machines stamped out panels by the thousand. Overhead conveyors moved wings through spray booths, where robotic arms hissed with paint. Workers rotated across shifts like clockwork, guided by charts, whistles, and routine. The system ran not on genius but on rhythm. They passed a section marked Final Assembly. There, fuselages, wings, and tail sections came together in a roaring ballet of riveters, cranes, and trolleys. The B-24s, sleek and silver, advanced one step closer to flight with every passing minute. The Germans stood in silence. One of them, an aeronautical engineer who had worked on the Heinkel He-177, muttered something under his breath. Impossible. An American interpreter turned to him. "What's that?" The man shook his head. "In Germany," he said softly, "this would take 1,000 engineers. You do it with 1,000 laborers." What shocked them most was not the machinery but the coordination. Willow Run operated like a military campaign. Materials arrived from 1,000 suppliers across the United States. Rubber from Akron, aluminum from Pittsburgh, engines from Dearborn, radio sets from Chicago. Trains rolled in on private sidings, unloading crates directly onto assembly platforms. Ford engineers tracked every shipment through an early data system, colored punch cards that recorded inventory and timing. Even downtime was measured in seconds. If one worker fell behind, another replaced them instantly. It was not art. It was orchestration. At one observation deck, a U.S. Army colonel pointed out the flow of production using a massive wall map. "Every time a bomber leaves this line," he said, "another replaces it within the hour." "We never stop." The Germans exchanged glances. Their own aircraft industry had collapsed under Allied bombing. Factories scattered, railways crippled, supplies exhausted. Yet here, in the heart of America, war production was accelerating even as victory approached. To them, this was not industry. It was an empire of motion. They toured the machine shops next, vast halls where precision tools hummed under fluorescent light. Lathes, presses, and gauges operated 24 hours a day. Engineers in white coats inspected parts against blueprints. The visitors recognized familiar patterns, gear ratios, propeller designs, but everything was scaled up beyond belief. One German, a metallurgist, stared at a rack of piston rings and whispered, "We could not even make the steel to feed such machines anymore." The interpreter nodded quietly. "That's the difference," he said. "You built for war. We built for work." During a break, they were taken to a cafeteria the size of a train station. Lines of workers, men, women, and even teenagers, ate in 15-minute rotations. Posters on the walls read, "Keep 'em flying and your work wins the war." A young woman carried her tray past one of the scientists and smiled. She had grease on her hands, her hair tied back under a bandana. The man, once an engineer in the Luftwaffe's research division, stared after her. In Germany, such women had been evacuated from the cities, not sent into factories. Here they built bombers. It was a quiet revelation, industrial democracy at work. The tour concluded in the test hangar. A newly completed B-24 stood gleaming beneath floodlights. Mechanics swarmed over it, checking hydraulics, fuel lines, and instruments. The smell of aviation fuel filled the air. Outside, a test pilot climbed into the cockpit. Engines coughed, then thundered to life, rattling the hangar doors. The ground trembled as propellers blurred into silver discs. The visitors watched as the giant aircraft rolled forward, paused at the runway, and lifted into the gray Michigan sky. It rose effortlessly, banking toward the clouds. "That one's going straight to England," said the foreman proudly. "Tomorrow she'll be flying over the Channel." The Germans followed its ascent until it vanished. No words were spoken. For men who had grown up believing Germany was the pinnacle of engineering, the experience was shattering. In the ruins of their homeland, production had been an act of survival. Here it was an act of mastery. They realized that America's true weapon was not a single plane, tank, or gun. It was the system that built them all. Machines could be destroyed. Factories could be rebuilt. But the capacity, the mindset to produce at this scale was something else entirely. It was the power to turn imagination into machinery overnight. As they boarded their transport vehicle back to the military base, one scientist lingered, staring through the windshield at the glowing expanse of Willow Run. Steam rose from its vents, like breath from a sleeping giant. Somewhere deep inside, another bomber was already taking shape, its rivets clattering like a pulse. "Now I understand," he murmured to himself. "We never had a chance." The engines roared to life. The convoy rolled into the dusk, leaving behind the living heart of American industry. For the first time, the men who had helped build Hitler's machines of war understood that their defeat had not come from the battlefield, but from the assembly line. And beyond the horizon, the thunder of production still echoed, unending, unstoppable, inevitable. The revelation of Willow Run wasn't a matter of admiration alone, it was an autopsy of defeat. The German scientists who toured it were not ordinary men. Among them were propulsion experts, metallurgists, and aeronautical engineers from the Luftwaffe's design bureaus, men who had worked on the Messerschmitt Me-262 jet fighter, the V-2 rocket, and the Heinkel bombers that once terrorized London. They had been trained to believe in precision, innovation, and technical supremacy. Yet standing inside the Ford plant, surrounded by the thunder of machines and the rhythm of industrial choreography, they saw something Germany had never mastered: scale. America had turned invention into multiplication, and multiplication into power. The secret lay in standardization. Ford's engineers had applied automobile logic to aviation, a feat that seemed insane in 1940. Airplanes, by their nature, were handcrafted, delicate, and unique. But Ford's production strategists under Charles Sorensen and Edsel Ford reimagined the B-24 Liberator as if it were a Model T on wings. Every bolt, panel, and wire was numbered, catalogued, and designed to fit perfectly with thousands of others. Where German factories relied on craftsmen and small-batch expertise, America relied on interchangeable parts and relentless uniformity. If one worker fell sick, another could replace him in minutes. If one machine broke, another picked up the slack. The result was consistency, every bomber identical, every output predictable. According to a 1943 War Department report, The margin of error in B-24 component production at Willow Run was less than 0.5%. That level of efficiency didn't happen by chance. It was engineered into existence. At the center of it all was Albert Kahn, the industrial architect who had already designed the massive River Rouge complex in Dearborn. His use of open-span steel and glass transformed factories into ecosystems of light and motion. Kahn's blueprints for Willow Run were masterpieces of industrial architecture, 1.5 million square feet of floor space, ventilated by fans that could clear smoke from an explosion in seconds. Wide corridors allowed forklifts to pass in both directions, and conveyor belts carried everything from rivets to entire fuselages across the plant. The German visitors noticed it immediately. The design was not just for machines, it was for movement. It allowed the flow of materials like blood through arteries. Each bomber that emerged from the assembly line contained 1,225,000 individual parts, from aluminum skins to hydraulic valves. And yet, because of Ford's logistics network, every component arrived within hours of being needed. Behind the factory's walls, a different kind of battle was being fought. A war of paperwork, shipping manifests, and production charts. IBM tabulators processed delivery schedules in real time. Clerks punched holes in stiff cards representing each engine, wheel, and control surface. Those cards were read by machines that coordinated procurement from over 1,000 suppliers. It was, in many ways, the world's first digital logistics network, a primitive ancestor of the computer-controlled assembly systems that would define modern industry. A technical bulletin from 1944 called it the invisible chain of victory. Germany's wartime production, by contrast, was fragmented. Rival ministries competed for labor and resources. Aircraft factories were spread across occupied territories, vulnerable to Allied bombing and rail disruption. Engineers like Willy Messerschmitt often spent as much time negotiating for aluminum as they did designing planes. By 1944, Germany's industrial machine was being held together by improvisation. Aircraft like the Me-262 and Arado 234 were technical marvels, but produced in dozens, not thousands. The Luftwaffe's records show that in January 1945, fewer than 300 jet aircraft had been delivered to combat units. Meanwhile, Willow Run alone produced over 650 B-24s that same month. The German scientists watching the Ford line knew the comparison instinctively. Innovation had been defeated by integration. Inside the factory, the Americans had perfected an art form called flow production. Every stage of manufacturing was synchronized with the next. Engines from the Ford Cleveland plant arrived on rail cars, rolled directly onto the line, and were fitted within hours. The Germans watched in disbelief as women workers, some barely 20 years old, calibrated instruments and installed oxygen lines. In their own country, aircraft construction was considered the domain of elite engineers. Here, ordinary citizens did it on a scale beyond comprehension. The Germans noted that each workstation had printed guides and diagrams showing exact steps, a teaching system that allowed untrained workers to perform skilled labor within days. "They have mechanized knowledge," one German whispered. "Even intelligence has been standardized." Perhaps the most astonishing revelation was time. Before the war, it took a German factory roughly 20,000 man-hours to complete a bomber. At Willow Run, it took 5,600. In mid-1944, the U.S. Army Air Forces reported that a B-24 left the assembly line every 63 minutes. The factory never slept. 3 shifts rotated endlessly, the lights burning through the night like a beacon. To the German visitors, it was industrial sorcery. "We built engines that could fly faster," one later remarked, "but we never built a system that could build faster." The Americans gave them a technical briefing in a conference room overlooking the floor. Charts covered the walls: production rates, defect ratios, fuel efficiencies. The scientists listened quietly as a Ford manager explained how continuous feedback loops kept the line running. Defects were traced back within hours. Adjustments were implemented the same day. In Peenemünde, such data would take weeks to process. At Willow Run, it took minutes. "Speed is not chaos," the manager told them. "Speed is control multiplied." The German delegation exchanged uneasy glances. Their empire had worshipped precision, but here precision served scale. When the tour continued, they saw the final assembly bay. the spiritual heart of the plant. Rows of completed bombers stood like metallic giants under skylights. Men and women in teams checked fuel pumps, control cables, and instrument panels with a surgeon's care. On a raised platform, a Ford supervisor shouted across the din, "If it doesn't fit, fix the part, not the plane." It was a philosophy as old as Fordism itself. No delays, no excuses, no perfectionism. The line never stopped moving. What the Germans could not ignore was the role of logistics beyond the factory. Ford's bombers required aluminum mined in Arkansas, copper from Montana, rubber from the Philippines, and fuel from Texas, each element arriving on schedule, coordinated by the U.S. Army Air Materiel Command. Behind every aircraft stood not just one company, but an entire nation of factories, railroads, and workers operating in perfect synchronization. For every bomber launched, 20 tons of raw material had been refined, processed, and shipped across thousands of miles. America's true genius was not invention, it was integration. The Germans left the factory floor and were escorted to a briefing on the plant's workforce. There they learned that nearly 1/3 of Willow Run's employees were women, another large portion were African American, and many were recent immigrants. The Reich's racial hierarchy would have never allowed such a workforce. Yet here diversity was production. "Every hand that can hold a wrench builds victory," a poster read. To the visitors it was another shock. The war they had fought was built on exclusion. The one they had lost was built on inclusion. As the tour ended, the scientists were silent. They had come to measure the enemy's industry, but what they found was a new kind of warfare, one that fought not with soldiers, but with systems. They understood now that this was how the Allies had crushed them, not by outthinking them, but by outbuilding them. The real secret weapon was not the atomic bomb or the radar set, it was the assembly line itself. Outside, night settled over Detroit. The glow of Willow Run lit the horizon, a furnace of motion and sound. A fresh B-24 rumbled down the runway and lifted into the dark. The Germans watched until its silhouette disappeared into the clouds. For a moment, no one spoke. Then one of them finally said what they all felt. This is what defeat looks like." By the summer of 1945, the men who had once built rockets for the Reich sat in stunned silence inside American offices. Their tour of Willow Run had stripped away the myth of German industrial invincibility. They had seen something their own nation had never truly possessed, a system where the power of production was as decisive as the power of weapons. It was not the complexity of American machinery that stunned them, it was the unity. Factories, supply lines, labor, and management all moved to one pulse. In Germany, industry had served the state. In America, industry had become the state's beating heart. That realization spread through the ranks of German scientists brought to the United States after the surrender. When Operation Paperclip began, many of them spoke quietly among themselves about what they had witnessed in Detroit. One rocket engineer remarked that Ford's assembly lines were more precise than the rocket plants of Peenemünde. Another, a metallurgist, noted that American mass production achieved the consistency that German laboratories could only dream of. They understood now why the Allies had never run out of planes, tanks, or trucks. Every loss had been replaced before the wreckage even cooled. Across the ocean, the remains of the Reich's industrial machine lay buried under rubble. Factories in Hamburg and Essen were silent shells, their roofs torn open by bombs, their machines twisted beyond repair. Even the mighty Krupp steelworks had fallen quiet. Where once men had worked in shifts around the clock, now weeds grew through the concrete. The power that had once fueled the Wehrmacht's blitzkrieg had simply vanished. It wasn't just defeat, it was erasure. Germany's industrial pride had been dismantled, its foundries drowned in silence. Meanwhile, in America, the transition from war to peace barely slowed the gears. Willow Run shifted overnight from bombers to civilian aircraft components and automobiles. The same lines that had produced machines of war now produced symbols of recovery. Ford's managers spoke of a conversion miracle, but the truth was simpler. The machinery of war had always been built to adapt. Flexibility was designed into its foundations. That adaptability stunned the visiting Germans even more than the wartime production figures. To them, rebuilding had meant starting from ashes. To America, rebuilding meant switching shifts. Psychologists from the U.S. Army's Interrogation Division later interviewed several of the visiting German experts. Their notes reveal something deeper than technical envy. It was existential shock. One scientist confessed that his greatest fear wasn't atomic warfare or Soviet occupation, but the realization that Germany had been beaten long before its armies collapsed. "We were already dead," he told the interviewer, "the moment your factories began." Another described the experience of standing inside Willow Run as like seeing a nation breathe. These were men who had helped build Hitler's vision of mechanized domination, and yet they had never imagined industry as a living force, an extension of national character. For American planners, Willow Run was more than a victory lap. It was a lesson in the future. Generals, engineers, and economists studied its methods for post-war policy. They saw that technology and organization could fuse into a weapon as potent as any bomb. The system that had defeated fascism could also define peace. It wasn't long before these lessons became the foundation of the Cold War arsenal. The jet age, the atomic project, the space race, all were descendants of the same philosophy born in factories like Willow Run. Production was power, and power was continuity. When the German scientists were later reassigned to laboratories in Texas, California, and Huntsville, many carried that memory with them. Some helped design America's next generation of aircraft and missiles. Others advised on manufacturing systems that borrowed directly from Ford's wartime logistics. They taught jet propulsion, but learned industrial discipline in return. Their new colleagues often joked that the Germans brought the brains, but we had the machines. Quietly, most of them agreed. In post-war Germany, the contrast was staggering. Cities like Stuttgart and Munich began rebuilding their industries under Allied supervision. Yet even as they restarted assembly lines, they could not replicate the scale they had witnessed in America. The cultural divide ran deep. German engineers still prized perfection. Americans prized output. In time, these philosophies would merge, the precision of one meeting the productivity of the other. But in 1945, the gulf was unbridgeable. German scientists spoke of the American factory not as a workplace, but as an organism that consumed resources and exhaled victory. Historians would later describe the Second World War as a contest of production curves. It was a war decided not by who built the better tank or the faster plane, but by who could build 10 of them before the enemy finished one. In that race, Willow Run had been the ultimate demonstration. At its peak, it produced more aircraft in a single day than all of Germany's underground factories combined. When Allied bombers pounded German cities, replacements rolled out of American plants before the smoke had cleared. That was the quiet arithmetic of supremacy, speed multiplied by endless capacity. Yet even among the Americans, there was awe at what they had achieved. Factory workers who once riveted wings went home at night, knowing they were part of something vast. They weren't soldiers, yet they had helped win a global war. Their pride filled letters, diaries, and interviews. A mechanic later wrote, "We didn't fight with guns. We fought with wrenches." It became part of a new American mythology, the idea that democracy itself could outproduce tyranny. While the enemy built monuments to power, America built power itself. The moral weight of that production wasn't lost on everyone. Some observers questioned whether a society so skilled at building weapons could ever fully return to peace. Economists warned of an industrial complex that might need constant conflict to stay alive. Yet for the moment, optimism triumphed. The world was exhausted, but America was reborn in steel and glass. Its cities gleamed with factories converted to peacetime production. Automobiles replaced bombers. Washing machines replaced turret guns. The same hands that had riveted warplanes now built the engines of prosperity. For the German scientists, the shock eventually gave way to respect. Many admitted privately that they admired the American system. They began to see industry not merely as a machine, but as a philosophy, a fusion of invention and organization. In their homeland, technology had been enslaved to ideology. In America, ideology had been built around technology. It was the ultimate inversion of everything they had believed. A system that empowered individuals to become part of something greater had defeated one that demanded obedience to the state. As one of them wrote years later, reflecting on that visit to Willow Run, "We had thought the future belonged to the men who could design the most powerful engines, but it belongs to the men who can build them by the thousand." His words captured the transformation of the modern world. The power of innovation had shifted from the laboratory to the factory floor. The new age of warfare and peace would be ruled by nations that could industrialize imagination. When the last of the Willow Run bombers left the runway in 1945, its engines roared over a world forever changed. The smoke trails it left behind were more than exhaust. They were the markings of a new order, one where production itself was destiny. The German scientists had come to study American machinery and left having seen America's soul. In the echoing halls of that factory, among the sparks and steel, they had glimpsed the true weapon of the 20th century, the ability to turn dreams into mass production. And as they looked back one final time at the glowing complex beneath the night sky, one thought bound them all, the realization that power was not in the genius of one man, but in the synchronized will of millions. That was the secret they had never understood. That was the engine that won the war.